Okay, so again, we are in the advanced statistics now, specifically with computer applications now. So the coverage of this course, of course, is describe some statistical techniques which are becoming increasingly common, particularly in the social sciences. No, the spread of sophisticated computer packages in the machinery on which to run them has meant that procedures which were previously only available to experienced researchers with access to expensive machines and research students can now be carried out in a few seconds by almost every undergraduate or in the graduate program. So the tendency of the packages to produce items of output which are unfamiliar to most users has led to modifications in the content of quantitative data analysis courses, but this has not always meant that the students gain an understanding of what the analytic procedures do. So when they should be used and what the results provided signify. So our aim for the advanced statistic has been to provide the basis for gaining such an understanding. So actually, there are many texts and internet resources covering the material which we do. So, but our experience is that many of them are too advanced, starting at too high at a level, including topics such as matrix algebra, which leave many students baffled. No? So, what we have attempted to provide is an assistance which will help you make the transitions from the simpler statistics, of course, the t-test, analysis of variance, to more complex procedures. So we are hoping we have translated the more technical text into a form which matches your understanding. So every chapter provides an outline of the statistical techniques, that type of questions it answers. So what the results produce tell you and gives example from published literature of how the technique has been used. So in recent years, there has been a considerable growth in the use of qualitative research method in many areas of social sciences, including psychology and nursing, and this has been accompanied by the decline in preponderance of quantitative research even in business, in government, in IT, and in other department. Now, one feature of the qualitative research movement has been as an emphasis upon the ethical issues involved in carrying out research, involving people, the need to recognize that the participants own their data and that they should have an output or input. So even perhaps a veto over the interpretation made of it and the uses to which it is put. The concern has rejuvenated the ethical debate within quantitative research and brought back an awareness of the need to ensure that participants give informed consent to taking part, that they are not studied unknowingly or covertly, that they have a right to confidentiality and anonymity. So this is not the place to discuss the ethics of research actually, but it is only proper that we should urge those considering quantitative research to be aware of the law, the ethical guidelines applicable to their discipline and ensure they abide them. So gathering the data which lend itself to quantitative analysis is not a value-free activity, even if number crunching. So may it itself be itself appear to be so. Before describing the more complex statistical techniques, we begin by recapitulating the basic of statistical analysis, reminding you of the analysis of variance and outlining the principles of the general linear model or the GLM, which underpins many of the techniques described in our some other chapter. So to discuss with us, to start with our advanced statistics, and again, as I mentioned, we need to start from the very beginning to remind us once again, to learn and relearn every one of us, for us to understand the advanced one. So we may start with the historical perspective of statistics. Okay, presenter, go ahead.
Hello po, good afternoon, Dean. Good afternoon, classmates. I'm Jenny Lindison, the first presenter for the day. So I'm going to discuss the historical perspective of statistics. First, let's define, of course, what is statistics. Definition of statistics. Statistics is a branch of mathematics dealing with the collection, analysis, interpretation, and presentation of masses of numerical data. In early times, the meaning was restricted to information about states, particularly demographics such as population. This was later extended to include all collections of information of all types, and later still it was extended to include the analysis and interpretation of such data. So in short, statistics is a collection of quantitative data, but then what is data? Data is a raw information and individual pieces of factual information that are recorded and used for the purpose of analysis. And the result of that data analysis is what we call the statistics. Further concept of statistics will be discussed by Sir Kevin, my group mate, and the uses of statistics, particularly in practical application, will be discussed also with my group mate. So let's see the etymology of the word statistics. So statistics derived from different words. So like in New Latin, statisticum collegium, which means council of state. In another Latin, which is status, means a station, position, place, order, or arrangement. In Italian, statista, which means statesman or politician. In French, statistic. And in German, statistic with a K, which first introduced by Gottfried Achenwald in 1749, which originally designated the analysis of data about the state, signifying the science of state, then called it in political arithmetic in English. Next slide. Okay. So now let's have a brief overview of the historical timeline of statistics. I will state the major information since there are so many names in bold with regards to statistics. So statistics was born as the science of kings. Kings used to collect and maintain quantitative information in relation to the population or manpower and material wealth of their countries. The purpose was to frame their military and fiscal policies as well as administrative requirements of the state. Statistics is as old as human society. It has been used also by ancient chief in counting effective warriors to defeat the enemy. In 30,050 to 4,000 BC, Indus Valley civilization studied tides and built structures. The ancient Babylonians used statistics to record crop yield. The ancient Egypt collected the data on population and material wealth of the country for the construction of pyramids. In 17th century to 18th century, the first recorded evidence of probability theory can be found as early as 1550 in the work of Girolamo Cardan. He wrote a manuscript in which he addressed the probability of certain outcomes in rolls of dice. So medyo familiar tayo doon. The problem of points and presented a crude definition of probability. But this manuscript has been lost, leaving the door open for further independent discovery. The first major accomplishment in the development of probability theory was the realization that one could actually predict to a certain degree of accuracy events which were yet to come. The second accomplishment, which was primarily addressed in the 1800s, was the idea that probability and statistics could converge to form a well-defined, firmly grounded science which seemingly has limitless applications and possibilities. It was the initial work of Pascal, Fermat, Grant, Bernoulli, Demois, and Laplace that set possibility theory and then statistics on its way to becoming the valuable inferential science that it is today. So si Blaise Pascal and Pierre de Fermat laid the fundamental groundwork of probability theory and are thereby accredited the fathers of probability, while Jacob Bernoulli and Abraham Demois were the two mathematicians who studied probability. Demois developed equation for the normal curve. Statistics began evolving in the 18th century in response to the novel needs of industrializing sovereign states. The evolution of statistics was, in particular, intimately connected with the development of European states following the Peace of Westphalia and with the development of which put statistics on a firm theoretical basis. So probability is now an indispensable tool of both social and natural sciences, which later on we discussed in Sir Kevin. Statistics may be used to have its origin in census, counts taken thousands of years ago as a distinct scientific discipline. However, it was developed. In 18th century to 19th century, so we have the inferential statistics and the statistics applied to education and sociology. So inferential statistics refers to all such methods by which conclusions are drawn relating to population on the basis of a given sample. In the early 19th century, statistics was developed as the study of populations, economies, and moral actions, and later as the mathematical tool for analyzing such numbers. So a famous Belgian statistician in the name of Adolf Quetelet applied statistics to investigation of social and educational problems. He was able to develop statistical theory on a general method of research to science. Then we have Francis Galton, who credited the concept of correlation or measures of agreement between two variables. Carl Pearson is another mathematician who collaborated with Galton in developing many of the correlations and regression formulas that are being used today. And James McLean Cattell, a famous psychologist who applies statistics method to psychology and educational problems together with his students. So until the last quarter of 19th century, the term statistics was used to express not only quantitative information, but also collected facts to explain the condition and prospect of society. And then in the 20th century up to the present, statistics widened day by day. So we have there the regression and correlation, and also with application of computer analysis. It is now fully developed science. So new techniques and methods were applied to study small samples by Ronald A. Fisher, who is the father of statistical method and applied statistics in genetics, biometry, and agriculture. So he's also the father of modern statistics, which is the ANOVA, or the analysis of variance. So at present, statistics is the major tool used by researchers in physical and social sciences, commerce, science, and technology. So, well, that's the end of my report for the historical perspective of statistics. And I will set the screen to the next reporter. Thank you.
And now